5 is stretches about the x or the y axis. So again, this lesson has two parts. The first part is exploring what the stretches do to the graph, and then the second part is using those stretches in the context of actual equation work. So we have the graph of f of x equals the square root of 4 minus x squared. Write an equation which represents y equals 3 times f of x. So what would my equation look like if it was 3 times f of x? It would be 3 times the square root of 4 minus x squared. So what I would like you to do is I would like you to use the graphing calculator and sketch those two graphs on a grid. Make sure you adjust your window settings so it goes from a -5 to a 5 and see what you get. Okay, so what do you notice about the graph? Give me some characteristics about this graph. Tell me about the x-intercepts. They stayed the same. Tell me about the y-intercept.
4 units up.
So where is it at?
6.
0 and 6. Okay? So, in general, what did the 3 do to the graph? Did it impact any of my x-coordinates? No. Which coordinates did it impact? The y. So it's going to be a vertical thing again. So we've had vertical reflections, we've had vertical translations. This time we have a vertical we call a stretch. So this affects the general sketch in that I have a vertical stretch. And when we stretch things by a factor. So if I look at the x-intercepts, there was no change. But if I look at the y-intercept, what was the original y-intercept? 2. And that went from 2 to what?
6.
6. So when we're talking about a factor, it's a multiplicative factor. So what would I multiply by 2 to get to 6? And where does the 3 come in? It was in the equation. So this becomes a vertical stretch by a factor of 3. So how does the number 3 affect the y-intercept? Well, 2 times 3 gives me my 6. Now, if we've got a vertical stretch happening, that 3 was actually with the y before it was brought over. So if I was to put the 3 over to the other side of the equation, what would I have gotten? Y divided by 3, which I can write as 1/3 y equals f of x. So that's what my equation originally would have looked like. So what's my replacement? I replaced y with a 1/3 y. And when I replaced y with a 1/3 y, I got a stretch by a factor of 3. So if I look at part 2, so if I look at part 2, it says, write an equation that represents y equals 1/2 f of x. Okay, so when I take a look at this, before we use the graphing calculator to sketch all of this, what was my replacement? So where was that 1/2 originally?
On the other side.
On the other side. And if I move it to the other side, what would I get?
2y.
So I get 2y equals f of x, which gives me a replacement of y to 2y. So what do you think, or sorry, let's start off with the equation. What would the equation look like for this 1/2 f of x? Y equals 4 minus, or sorry, the square root of 4 minus x squared.
Y equals 1/2 square root.
So it'd be 1/2 root 4 minus x squared. So then when I put that into my graphing calculator, what do you think is going to happen to the graph?
It's gonna have a vertical stretch by a factor of -2.
By a factor of what?
Would it be -2?
Would it be
Is
negative?
goes down? Like, well,
So let's look at the y-intercept, because the y-intercept is going to help us. We went from 2 to 1. What can I multiply by 2 to get to 1? 1/2. So 2 times 1/2 equals 1. So that 1/2, that's my stretch factor. So I have a vertical stretch by a factor of 1/2. And when we say the vertical stretch, we do put in another statement, because I have to state what axis I'm stretching this over, or what my anchor is. My anchor is the x-axis, because when I'm doing my vertical stretch, it's like I'm standing on whatever points are on the x-axis, and I'm pulling the graph from that point. So I've stood on these two intercepts, and I've either pulled it up, or in a sense pushed it down. So I have a vertical stretch about the x-axis by a factor of 1/2. So then the one above that would be a vertical stretch about the x-axis by a factor of 3. So again, if you look at my replacements, I replaced y with a 2y, and my stretch factor is 1/2. I replaced y with a 1/3 y, and my stretch factor was 3. What's the relationship between these two numbers? What kind of numbers are they? Not inverse. Starts with an R. They're reciprocals of each other. So if we complete the following statements, compared to the graph of y equals f of x, the graph of y equals a times f of x results in a vertical stretch about the x-axis. And because a has been moved over to the right-hand side of the equation, the factor matches that value. But originally, we need to remember that the replacement was a y equals 1 over ay. So when it's written in this form right here, this becomes a vertical stretch by a factor of a. It's the reciprocal of that value. Okay, so that's examining what a does to the graph. Now we're going to look at two functions, y equals f of x and y equals f of b times x, where b is a number that's greater than 0. So we start off with the same equation that we had before, 4 minus x squared. It says write an equation which represents f where I see an x, what would I substitute in? And then if I take 4x and I square it, (16x squared). So now if I graph that and sketch the graph on the grid. What do you notice about this graph? What stayed the same and what changed?
The y-intercept didn't change.
Okay, the y-intercept stayed the same. What about the x-intercepts? Did they stay the same? Where did they move to? They were at 2. And where did they go to?
1.
Pardon?
1.
Are they at 1? Like this should be half. If I zoomed in. So it says, describe how the number 4 in y equals f of 4x affects the graph. What's moving here? The x's or the y's? X's, which makes this horizontal. And it's a horizontal stretch. What's my anchor line? The y-axis this time. So it's a horizontal stretch about the y-axis by a factor, and we'll leave the factor blank for now because we'll do the other two. So what didn't have a change? The y-intercept. Because the y-intercept is y values, and I'm doing something to the horizontal values. The x-intercepts went from 2 to 1/2. What can I multiply by 2 to get to a half? 1/4. 2 times 1/4 equals 1/2. Where do I find the 1/4? What can I use to help me get the 1/4? Take the reciprocal of that 4. So that becomes my stretch factor. It's a factor of 1/4. My replacement was replacing x with a 4x. And my stretch factor becomes 1/4. So then we'll look at one more. So if we look at y equals f of 1/3 x, what would my equation look like? What would my equation be? Y equals what? And when I square 1/3 x, what do I get? Okay, so before we put this into the graphing calculator, what was my replacement? What did I replace x with?
1/3.
And if I follow what I did above, what would my factor then be?
3.
My factor would be 3. So what would change, my x or my y-intercepts? My x's. So my x-intercepts are at 2. Where do you think they're going to go to? 6. A plus and minus 6. Because 2 times 3 would give me my 6. No change. on the y values. So now put it into your calculator and sketch what this looks like and see if that happens, if those results happen. No change to the y-intercept, and the x's become negative and positive 6. So you might have to extend your window settings to include that. Is that what I get? So I have a horizontal stretch about the x-axis, or sorry, not x, y-axis, about the y-axis by a factor of 3. So if I go down to the statement that's at the bottom, complete using the results from part 1 and part 2, compared to the graph of y equals f of x, the graph of y equals f of b times x results in a horizontal stretch about the y-axis by a factor of 1 over b. And again, if we look at the replacement, we're replacing x with a b of x. And my factor is the reciprocal, which is the exact same thing that I did with my vertical replacement. When I replaced y with a times y, my factor was a 1 over a. It looks a bit different simply because we always move the y to the other side of the equation. But all of my replacements always went the same. When I went y minus k, it was to move up. So when I go a times y, it's a factor of 1 over a. So what happens if a is negative? So if I have the equation x cubed minus 2x squared minus 5x plus 6, and I replace the equation with a negative 3, I would get negative 3 times this entire equation. And then when I do my replacements, negative 3, or not my replacements, when I remove the brackets, negative 3x cubed, 6x squared, 15x minus 18. Sketch that on your calculator and tell me what you see. So did anything stay the same in the graph? The x-intercepts all stayed right where they were, okay? What happened to this part of the graph right here? This part that kind of went up and then down? Where did it go? You've got the picture in front of you. You know what it did. Just tell me what it did.
Well, it looks like it got reflected down, but then it got stretched too.
That's exactly what happened. So I have two things going on. So if I look at this 3, when it was on the other side of the equation, what was it? What was my replacement? Y with a negative 1/3 y. Okay, so now if I ignore the negative for a moment and I think of the 1/3, that 1/3 gives me a factor of 3. So if I stretch this by a factor of 3, I'm going to go from 8 to 24, right? Stretch by a factor is going to bring me up to 24. But then what does that negative tell me to do?
Reflected through the y-axis.
reflected in the y-axis. So my positive 24 is going to become negative 24, which is why it moved down to here. So then if I look at this part of the graph right here, it was at negative 4, and where did it seem to move to?
Positive 8.
Did it go to positive 8 or positive 12?
Probably positive 12.
Why 12 and not 8?
4 times 3.
4 times 3. So 4 times 3 would give me the negative 12, but then the reflection would give me the positive. So then this part of the graph right here, when it's reflected, means it's going to go up. This part of the graph that was up is going to come down. So what I end up with is I get this picture that goes like this. If I could draw it properly. And that's what your calculator gave you. But now we have a better understanding of why the calculator gave us that. Because what we had says, describe how the number negative 3 in the equation y equals negative 3 f of x affects the general sketch. And as Rachel pointed out, it looks like I have a reflection in the x-axis and a vertical stretch about the x-axis by a factor of 3. What happens to the x-intercepts? They stay the same. There's no change. And why do they stay the same? Because the y-coordinate was equal to 0. And when I multiply 0 by the factor of 3, it's still 0. When I reflect it, it's still 0. What happened to the y-intercept? So the y-intercept was at 6. Where does the y-intercept move to? I was at 6.
It's negative 18.
And it goes to negative 18. 6 times negative 3. So it's multiplied by negative 3. So compared to the graph of y equals f of x, the graph of y equals a times f of x when a is less than 0, so when a is a negative value, results in a vertical stretch about the x-axis by a factor of the absolute value of a, followed by a reflection in the x-axis. And remember, they're talking about the equation being in its simplified form of a times f of x. Originally, it would have looked like 1 over a, negative 1 over a times y equals f of x. And we've moved that to the other side to get that negative a value. So what do you think happens when we replace f of x with f of b times x and I make my b value less than 0?
Reflection in the y-axis and the horizontal.
So we're going to look for a reflection in the y-axis and we're going to look for a horizontal stretch. So if I was to write an equation that represents f of negative 1/3 x, that means in this equation, wherever I see an x, I'm going to substitute in a negative 1/3. So I will get negative 1/3 x all cubed minus 2 times negative 1/3 x, which would be squared, minus 5 times negative 1/3 x, plus 6. So when I take negative 1/3 and I cube it, what will I get? So cube the top, negative 1 cubed would be negative 1, and 3 cubed would be 27. So I get negative 127 x cubed. If I take negative 1/3 and I square it, I get positive 1/9, which when I multiply by 2 gives me negative 2/9 x squared. If I take negative 5 and multiply it by negative 1/3,
Negative 5/3. Positive 5/3.
positive 5/3 plus 6. So we're looking for a reflection in the y-axis. And what am I looking for a stretch factor? What's my stretch factor going to be? What was my replacement? What did I replace x with? Negative 1/3. So what's my stretch factor? If my replacement is a 1/3, my stretch factor is going to be negative 3, or just 3. So when we talk about our stretch factor, it's just a 3. So if I was to look at this without using my graphing calculator, my negative 2 stretches by 3, which means it's negative 6, but then it reflects to become positive 6. So there's 1 point. My positive 1 stretches to be 3, reflects to be negative 3. My point of 3 stretches to 9, reflects to negative 9. And then these 2 points in here, this looks like maybe about a 2, stretch to 6, reflect to negative 6. And then this final one that looks like maybe it's about at negative 1, would stretch to 3 and then reflect to positive 3. Just so that I can have something to connect my dots with. So when I connect my dots, I get a graph that will look like this. This point here, 0 and 4, stays the same. So now check that with your calculator. And in this instance, it's a little bit more work, but it would be more useful if you put both equations on the calculator. This one takes a long time to write in, doesn't it? you get that kind of a graph? Okay, so then let's go to the bottom part.